Sharing screen. No, this one. Okay, cool. All right, so we're going to be stepping through our diagram for everybody who likes diagrams. So this is another sort of thing that you could, as you're studying, write out for yourself. So write in what increases, what decreases, because this is all a pathway that's happening in order to lead us to breathing in or breathing out. Okay. So we're going to start out with our motor neurons and their neural input. So their signal out to the body. Okay. So our neurons sending signals out to the body telling us we want to breathe in. Okay. So they're going to be sending that signal to our inspiratory muscles. When your nerves send a signal to a muscle, we know from A&P1 that means they're releasing our neurotransmitters, acetylcholine, because this is going to be skeletal muscle, right? So that muscle is taking in that neurotransmitter, its response is to contract those sarcomeres, right? So our muscles are contracting in response to neural input. Specifically, it's the diaphragm and the external intercostals. So when they contract, when they get shorter, the diaphragm makes the chest bigger up and down. The external intercostals make the chest wider, side to side and front to back. So our chest wall overall is expanding. Okay? As it expands, it pulls on the intrapleural fluid. So there's a little bit of fluid between the parietal and visceral layers of the pleura. That's our sac around the lungs. Okay? So it's pulling on that fluid, pulling it out. It experiences surface tension that allows the pleura on the lung itself to follow along with it. Okay? So we might write that out in terms of numbers or measured pressures, that our intrapleural pressure is going down, creating an increase in transpulmonary pressure. That increase in transpulmonary pressure pulls on the alveoli, increasing their volume. So they're increasing their volume. When we see an increase in volume, that means we're going to see a corresponding decrease in pressure until we have something move in or out. Okay. So this is how we make our intra-alveolar pressure go down. Okay. Then we're going to see that transpulmonary pressure, not the transpulmonary pressure anymore. So now we're looking at that pressure gradient between the atmosphere and the alveoli. So we've changed that pressure gradient. We now have an increase in the pressure gradient, but really all we need to do is compare which number is bigger, which is larger. We're just doing that mathematically now. So we have a low intra-alveolar pressure here. Okay. So we are then going to see air flowing into the alveoli. So that's overall how we get air into our alveolus, into the lung. This is a negative feedback loop because now that we have air flowing in, so now that we're filling up our container, this raises the pressure because we have a trade-off again. So we're raising the pressure because we now have stuff filling that volume. So as we see a raise in pressure, this acts as a negative feedback loop essentially. Right, so we're then going to see the opposite change. So this is overall picking out what happens to kick this off, what our end result is, and then all the steps that take us to get there. Okay. So here we're looking again at that image of our pressures and our breath volume, but now instead of just looking at alveolar pressure, we're looking at our relationship to atmospheric pressure and intrapleural pressure. So before we were just following this curve, right? So this is the curve we walked through kind of at the beginning of lecture. That was our pressure in the alveoli. Now we can also see what's going on with the transpulmonary pressure and the intrapleural pressure at the same time. Okay. So what we see happening as your muscles contract, right? So your muscles are contracting, they're pulling on that intrapleural space, on the fluid in it. Okay. So pulling on it, they're making it larger. Okay, so we're seeing a drop in that pressure, right? So it's going down. Okay, and that transpulmonary pressure drops until we're at rest. Then you relax your muscles. They basically cave back in everything in the chest. So that pressure goes up a bit more. Okay, so we can now measure the transpulmonary pressure, the difference between those changing as well. All I want you to know conceptually really is that that transpulmonary pressure is a result in changes to the intrapleural pressure caused by changes in the size of the chest wall and the muscles. Okay, and this is one of our forces for changing that alveolar pressure. So we can see this here kind of drawn out. So our transpulmonary pressure is just that measure across the wall here. Okay. So as I mentioned, as I was trying to guide you as we were breathing in, right? Breathe in, use your muscles. Breathe out, you can just relax. Expiration is normally a passive process, right? So we're just going to see that when our muscles relax, that diaphragm bows back up, right? Makes that curve again. The chest wall drops those ribs back down and in. Okay? So we see a decrease in the volume of the thoracic cavity just by relaxing the muscles. So to breathe out, we don't really have to do anything. Okay? In order to breathe forcefully out, like if we're coughing or if we're breathing really hard after exercising, right? We want to ventilate rapidly, move gas really rapidly. That's when you would see the actual activation of the muscles used in expiration. Okay, so you do sometimes want to breathe out more air than usual. So that's when you would actually be using those internal intercostal muscles and the abdominal muscles. Usually we're just looking at elastic recoil and the relaxation of muscles. So, you know what? This is a new lecture, so why don't we end 5 minutes early for once? So we'll pick up here with our factors for pulmonary ventilation. Okay.